We do need to also deal with the idea of dividing one fraction by another. So think of 3/7 then divided by the fraction 5/11. And we can actually relate what we need to do in terms of all of the ideas we have seen. So this way of writing the answer looks rather long, but please bear with me for a second. What I'd like to do is show you using the things that we've already discussed as being okay things to do, um, how to get an answer to this question, and then we will talk about a slight shortcut. The shortcut you are probably familiar with, but I think it's important to see this method first and then relate this method with, and in the method we're about to do, you'll understand, I hope, all the steps because we have covered each of the concepts and justified why each of the pieces or concepts work earlier. And then I'll connect it to a shortcut you may have learned. The only way I know how to explain how the shortcut works, to be really honest with you, is that this process I'm showing you works. So what I do, or one way to do this, again, this is a very long-winded approach, but it's helpful to see, is I'd like to take this huge old fraction, right? It's a fraction over a fraction. So it's a huge fraction where the numerator is a fraction. The numerator is 3/7, and the denominator is 5/11. So it's a fraction with fractions inside it. And I'd like to multiply. You can multiply by whatever you want on top and bottom, and I chose to multiply the top and bottom by 11/5. And I need to write that both on top and on bottom. Where did I get the 11/5? Well, you're going to see in a moment why I chose that. It's completely valid to multiply the top and bottom of a fraction by 2 or by 10 or by a fraction. And so I chose to multiply the top and bottom of this fraction by the fraction 11/5. And then what I'm going to do is I'm going to leave in the numerator 3/7 times 11/5 alone. I'm just going to copy that. In the denominator, I have 5/11 times 11/55, and we just talked about what it looks like to multiply fractions. So down here, in the denominator of this big old fraction, where you have a fraction times a fraction, I'm going to use that concept we just saw of multiply straight across. So 5 times 11 is 55, and then the denominators here of 11 times 5 is that 55 right there. Then I'm going to keep the numerator still the same. I could have simplified, but I'm intentionally not to try to connect it to another way you have seen this perhaps before. But what I am going to do is in the denominator, it says 55 over 55. I'm now going to use the interpretation of the cats and boxes approach to fractions. That's going to be more helpful right now. To think about how if you have 55 cats and 55 boxes, then there would be one cat per box. So 55 over 55 simplifies to 1. Now, I'd like to go back and remind you, we talked about how when you have an over 1, you can just leave off the over 1, right? Just in the same way that if you had something that isn't a fraction, you could put it over 1. So you can insert an over 1 or you can remove an over 1. So that then we just have what's in the numerator of this big old fraction. You have 3/7 times 11/5. Then, since it is one fraction times another, 3/7 times 11/5 looks much less scary than this monstrosity we started with. We end up with 3 times 11 is 33, multiplying straight across, and 7 times 5 is 35, multiplying straight across. And we are done. But what I'd like to then point out is, I'd like to point out that all of the steps we did are justified bit by bit, one step at a time, by a concept that we have talked about and we've justified why it works, why it's a thing. But the way you have probably seen it is jumping from what you see highlighted in red at the beginning of the answer to the second to last step highlighted in red. I would encourage you to actually go ahead and skip these steps in the middle because it is a lot to write. But the point I want to make right now is I have no other explanation I can come up with, even to someone who's studied a lot of math. This is really the only way I can explain all of the steps in the middle. I just wanted you to see it once. I just wanted you to see where this comes from. That dividing one fraction by another, one fraction divided by a second fraction, is the same as multiplying by the reciprocal of the second fraction. You've probably heard this, that to divide by 5/11, for instance, is to multiply by 11/5. Right, so yeah, fraction divided by fraction is the same as first fraction times reciprocal of second fraction. So the justification, you see it in this large answer here. Just to clarify, though, it was to multiply. We multiplied the top and bottom by 11/5 in this example. We applied the fraction multiplication rule just in the 5/11 times 11/5. Multiplying straight across, we did this cats and boxes interpretation, and then we decided, hey, there was really no need to write the over 1 part. So we did show all the steps, just in this example, to justify why this works. But in the future, please feel free to jump directly from 3/7 divided by 5/11 to 3/7 times 11/5. But the whole reason this works is justified here with a bunch of individual steps. And even those individual steps, we had justified why those things work earlier. Now, I'd like to end on a couple kind of loose ends related to fractions, things that will help us out. Please never write 2 1/3. Mixed fractions are not ever written in higher math because the writing ends up being ambiguous. So instead, the thing is, when you mean 2 1/3, what's really going on is this is 2 plus 1/3. And the way to write this, the way to simplify this, is to write the 2 as 2 over 1, which becomes 6 over 3. So 6 over 3 plus 1 over 3 is 7 over 3. So please write 7/3 instead. I know that this thing tends to be called like an improper fraction. It makes it sound like it's the wrong kind of thing, but it's actually the preferred format in a higher level math class. So in higher math, the issue is that writing like this, even if you intend this to mean 2 1/3, this is really interpreted as 2 times 1/3, meaning this is 2 over 1 times 1 over 3, which ends up just being the number 2/3. So 2/3 is not the same as 7/3, right? Yeah, we've got to make sure that writing something only intends one thing. It shouldn't mean two different things. And it's an unfortunate thing that in everyday life, and in everyday life I do it too, that in everyday life I would write 2 1/3. And I know what is meant by that when I see like a street sign talking about how many hours of parking you have. But unfortunately, in mathematical notation, we're going to have to really settle on a standard, and the standard will be to interpret this not as 2 1/3, but instead as 2 times 1/3, because if there's no symbol in between, it should be interpreted to be a multiplication. Just a word about minus signs. If you have a minus sign in front of a fraction, then you have that fraction in its negative value, in the negative value form. And the thing is, there are a couple other ways to write that fraction where the value would remain the same. So you could, instead of having the minus sign in front of the fraction, it can be part of the numerator or it can be part of the denominator. These all mean the same thing. Just have one minus sign, though. You don't want to think of like, it doesn't mean this minus sign distributes to the top and bottom. It's just the fraction's value in negative form. So for instance, negative 3/5 is equal to negative 3 over 5, which is equal to 3 over negative 5. All three fractions are equal. With two minus signs, the fraction's value overall becomes positive. That is, negative 3 divided by negative 5, right? Fraction means dividing. So when you divide two negatives, you get a positive. So this would simplify to 3/5 positive. The original U.S. Constitution counted enslaved people to be 3/5 of a person for congressional representation. So it's actually interesting to think about what's bigger, 3/5 or 3/5 times 3/5. Well, you should work out what 3/5 times 3/5 is. So be sure not to cross multiply. Be sure to multiply straight across and think about the value of the fraction you get. It should be 9/25. And think about what generational wealth does. It really does have a multiplicative factor, and it would be really interesting to punch into a calculator just to see what's going on. What is 3/5 and what is 9/25? Here's an example that I remember a friend of mine had asked about. I think it's actually very useful if you bake to think about something like this. Your favorite cookie recipe calls for 3 1/4 cups of flour. How much flour is needed for doubling the recipe? So first of all, we go back to this point earlier that we'll never write mixed fractions. In a recipe book, you're probably going to see something like 3 1/4. But instead, we've got to turn this into 3 plus 1/4. So 3 over 1 plus 1 over 4, right? I think it's awkward to try to add a non-fraction like 3 to a fraction like 1/4. So let's turn 3 into a fraction, 3 over 1. But then to simplify adding these fractions, we're going to need a common denominator. So let's multiply by 4 on top and bottom of 3 over 1. And then we'll end up with 12/4 plus 1/4. Now that we have a common denominator, we can apply the fraction addition rule to get 13/4. So we haven't done anything with the doubling the recipe part. This is just 13/4 cups of flour. Now we know how much flour we need in a more mathematical format instead of in the everyday mixed fraction format. So if one batch needs 13/4 cups of flour, to double the batch, we need 2 times 13/4. So I want to talk about this notation here. What's written here is correct. And this does not mean that you multiply by 2 on top and bottom. That is creating some notational error that's going to create a bad habit. It's going to make things go wrong in the future. This is really 2 times 13/4, meaning we can convert the 2, which doesn't look like a fraction yet, into 2 over 1. So 2 over 1 times 13 over 4. Remember, for fraction multiplication, you multiply straight across. So you have 2 times 13 is 26, and 1 times 4 is 4. If we like, we could now actually reduce this fraction a bit. There's a hiding times 2 on top and on bottom. So there's just an arithmetic step to turn 26 into 13 times 2 and to turn 4 into 2 times 2. And since it is a times 2 on top and a times 2 on bottom, those are the only things that can cancel in a fraction. So in this fraction, on top and bottom, we're going to cancel a times 2 and be left with 13 over 2. So in conclusion, we need 13 over 2 cups of flour. What I would do for a recipe like this is I would take my half cup measure, because of this half down here, and I just fill that thing 13 times. Just to clarify, because this is a common notational error, sometimes students will write 2 in parentheses or not, doesn't matter, but they'll write that and then 13 over 4 to mean taking 13/4 and multiplying by 2 on top and bottom. That's not what this means, okay? So the only way to get that is to write 13 times 2 over 4 times 2. If you really mean times 2 on top and bottom, you need to write the 2 both on top and on bottom. Writing like this is not going to serve that purpose, because writing like that ends up creating a fraction of different value. You notice just up here that 2 times 13/4 meant 2 over 1 times 13 over 4, and that simplified to 13 over 2. And that's a different value fraction than what you get if you were to multiply by 2 on top and bottom, because if you multiply by 2 on top and bottom, you should actually get a new fraction whose value is the same as the original 13 over 4.